Good morning, all of you. So, in before classes, we discuss about what is generating functions. Uh, so, the basic general form of generating function is g of x is equal to a naught plus a1x plus a2x square plus and so on plus an minus 1 x power n minus 1 and is equal to closed form summation n is equal to 0 to infinity a r x power r. Okay. So some binomial expansions and its closed form 1 plus x whole power n is equal to summation r is equal to 0 to n ncr x power r 1 minus x whole power n is equal to summation r is equal to 0 to n ncr minus x whole power r 1 plus x whole power minus n is equal to summation r is equal to 0 to infinity n plus r minus 1 cr n minus x whole power r and 1 minus x whole power minus n is equal to summation r is equal to 0 to infinity n plus r minus 1 cr x power r. Okay. So I already discussed about what is the general function and then what we discuss about how to find the general functions of sequences. So in today class, we are going to discuss about counting technique. Okay. So what is counting technique? So let the number of the integer solutions of the equation is x1 plus x2 plus x3 plus and so on plus xn is equal to 0 or x1 plus x2 plus x3 plus and so on plus xn is equal to r where n greater than or equal to r greater than or equal to 0. Okay. So here x1 can take the positive values, integer values uh, depending on given constraints. Constraint means conditions. So x1 value can take the integer values based on the given constraints and x2 also can take the integer values based on given constraints and so on. Xn can take the values that values pn1, pn2 and so on pn3. Okay. To solve this type of problem, first we have to define functions f1x, f2x, fnx as follows. So, what is the function here? f1x is equal to x power p11 plus x power p12 plus x power p13 plus and so on. So, here p11, p12, p13 represents the positive integer values. It taken based on given constraints. Okay. So f2 of x power p21, x power p22 plus x power p23 plus and so on. And so on fn of x is equal to x power pn1 plus x power pn2 plus x power pn3 plus and so on. Okay. So now we consider the generating function f of x defined by f of x is equal to f1 of x into f2 of x into f3 of x into and so on into fn of x. So we get the generating function, the product of these all functions. What we define the functions based on given constraints. Okay. This is called counting technique. So next problems. Find the generating function that determines the number of negative integer solutions of equation x1 plus x2 plus x3 plus x4 plus x5 is equal to 20. So here the given equation is x1 plus x2 plus x3 plus x4 plus x5 is equal to 20. Under the constraints, constraint means given conditions are x1 less than or equal to 3, x2 less than or equal to 4, 2 less than or equal to x3 less than or equal to 6, x4 less than or equal to 5, x5 is odd with x5 less than or equal to 9. These are the conditions for the given equations. Okay. So using these constraints and the function, we have to find the generating function for the given equation. The given equation is x1 plus x2 plus x3 plus x4 plus x5 is equal to 20. Okay. So first constraint for x1 is x1 less than or equal to 3. So we have to take the integer values less than or equal to 3 means 0, 1, 2, 3. So the integer values for x1 is 0, 1, 2, 3. So next we define function for x1. So that function is f1 of x is equal to x power p1. Here p1 is 0, p1 1, 1. Okay. Next value 2, next value 3. So using these integer values, we define the function f1 of x is equal to x power 0 plus x power 1 plus x square plus x cube. Okay. So next given constraint is x2 less than or equal to 4. x2 less than or equal to 4. So we have to take x to take the integer values 0, 1, 2, 3, 4. So the function defined on x2 is f2 of x is equal to x power 0, x power 1 plus x square plus x cube plus x power 4. Okay. And next constraint is 2 less than or equal to x3 less than or equal to 6. So x3 can take the integer values 2 to 6. Okay. So that is 2, 3, 4, 5, 6. So the function defined on x3 is f3 of x is equal to x square plus x cube plus x power 4 plus x power 5 plus x power 6. Okay. So next constraint is x power 4 less than or equal to 5. So x power take integer values 0, 1. So here the condition is x power 4 less than or equal to 5 means x power 4 can take the values 0, 1, 2, 3, 4, 5. So the function defined on x4 is x power 0 plus x power 1 plus x square plus x cube plus x power 4 plus x power 5. Okay. So and the condition for x5 is x5 less than or equal to 9, but we have to take odd integer values. So in given problem, the condition of x power x5 is x5 can take odd values between x5 less than or equal to 9 annaru. So x3 can, sorry, here it is x5. x5 can take the odd integers 1, 3, 5, 7. Okay. x5 can take odd integers 1, 3, 5, 7, 9. So the function defined for x5 is equal to x power 1. So here see the values 1, 3, 5, 7, 9. These are all odd numbers. Okay, which satisfies the condition x5 less than or equal to 9. So the function for x5 is f5 of x is equal to x power 1 plus x cube plus x power 5 plus x power 7 plus x power 9. Okay. So these are all the functions for given constraints. So now we have to find the generating function. So how to get generating function using these functions? So what is the formula? F of x is equal to f1 of x into f2 of x into f3 of x into f4 of x into f5 of x. So f1 of x, x power 0 plus x1 plus x square plus x cube into x power 0 plus x power 1 plus x square plus x cube plus x power 4 into x square plus x cube plus x power 4 plus x power 5 plus x power 6 into x power 0 plus x power 1 plus x square plus x cube plus x power 4 plus x power 5 into x power 1 plus x cube plus x power 5 plus x power 7 plus x power 9. This is the generating function for the given equation. Okay. This is how we find the generating function for given equation and their constraints. Okay, using counting techniques. Next problem. Find the number of integer solution of the equation x1 plus x2 plus x3 plus x4 plus x5 is equal to 30 under the constraint xi greater than or equal to 0 for I is equal to 1, 2, 3, 4, 5 and further x2 is even and x3 is odd. So here we have to find the number of integers. Okay, number of integers means uh, we have to find the x power 30. Here total integers is equal to 30. So number of integers is 30 means x power 30. We have to find the coefficient of x power 30 in this problem. Okay. The given constraints are xi greater than or equal to 0 for I is equal to 1, 2, 3, 4, 5. Okay, means x1, x2, x3, x4, x5. And given condition for x2 is even. We have to take integer values for x2 is even only. And we have to take integer solutions for x3 is odd integers only. Okay, these are the given conditions for the given equation. So now we have to find the number of integer solutions, means here the total number of integers is 30. So we have to find the coefficient of x power 30. Okay, so solution given equation is x1 plus x2 plus x3 plus x4 plus x5 is equal to 30. So given constraint is xi greater than or equal to 0. Okay. So we have to find the coefficient of x power 30. So for the given constraints we have, so given constraints ఏంటి xi greater than or equal to 0 అంటే x1 కి values ఏముంటాయి 1 2 3 4 and so on. There is no condition, just the given condition is xi greater than or equal to 0. So the positive integer values we have to take satisfies this condition. Okay, so for the given constraints we have we write direct functions here because there is no individual constraint here. So we go for directly with functions. F1 of x is equal to x power 0 plus x1 plus x square plus x power 3 plus x power 4 plus x power 5 and so on. Okay. So this is the expansion for binomial expansion for 1 minus x whole power minus 1. Okay, 1 minus x whole power minus 1. So next condition is the constraint for x2 is we have to take only even values. Okay, so 0, 2, 4, 6, 8, 10, 12 and so on. So the function for x2 is f2 of x is equal to x power 0 plus x square plus x power 4 plus and so on. So this is the binomial expansion for 1 minus x square whole power minus 1. Okay, 1 minus x square whole power minus 1. So next f3 of x. So the condition we have x3 is only we have to take odd values. So the series starts with x power 1 plus x cube plus x power 5 plus x power 7 plus x power 9 plus x power 11 and so on. So in this expansion, x will be common. Remaining expansion is x power 0 plus x square plus x power 4 plus x power 6 plus and so on. So this is the binomial expansion for 1 minus x square whole power minus 1. So f3 of x is equal to x into 1 minus x square whole power minus 1. So f4 of x is equal to x power 0 plus x power 1 plus x square plus x3 x cube plus and so on. So this is also binomial expansion for 1 minus x whole power minus 1. Okay. f5 of x is equal to x power 0 plus x power 1 plus x square plus x cube plus and so on. 1 minus x whole power minus 1. These are the functions for given constraints. So first we write the generating function for this equation. So the generating function is f of x is equal to f1 of x into f2 of x into f3 of x into f4 of x into f5 of x. So 1 minus x whole power minus 1, 1 minus x square whole power minus 1, x into f3 of x means x into 1 minus x square whole power minus 1, 1 minus x whole power minus 1, 1 minus x whole power minus 1. So here bases are equal, powers add చేస్తున్నాము. So we get 1 minus x whole power minus 3. So minus 1, minus 1, minus 1. So total minus 3. So here 1 minus x square terms 2 ఉన్నాయి. So 1 minus x square whole power minus 2. So x constant. So x into 1 minus x whole power minus 3 into 1 minus x square whole power minus 2. Okay. So in this form, we have to find the coefficient of x power 30. So this is of the form 1 minus x whole power minus n. 1 minus x whole power minus n. So here also 1 minus x square whole power minus n. So here x value is equal to x square. X value is equal to x square. So what is the formula for 1 minus x whole power minus n? Summation r is equal to 0 to infinity n plus r minus 1 r x power r. So here also summation s is equal to 0 to infinity. We consider here another variable to show difference for these two functions. So summation s is equal to 0 to infinity n plus s minus 1 s x power s. Okay. So here x bases are equal, powers act as a term x power r plus 1. Here in this function n value is equal to 3. In this function n is equal to 3, x is equal to x itself. Okay. So we substitute n value 3 plus r minus 1 r x power r plus 1. Okay. So in this expansion, x is equal to x square and n is equal to 2. We substitute these two values. So 2 plus s minus 1 s in place of x square 2 x square whole power s. Okay. So summation r is equal to 0 to infinity 3 minus 1 2 plus r x power r plus 1 summation s is equal to 0 to infinity 1 plus s x power 2s. Okay. So using this expansion we have to find x power 30 coefficient. X power 30 coefficient. So here x value 2s, here x power value r plus 1. For given values for s and r, we get x power 30 in this total product. Okay. So now we take s is equal to 0. We take s is equal to 0, r is equal to 0. So we get 1, 0. Okay, for this expansion 1 plus 0, 0, x power 2 into 0, 0. So x power 0, 1. So here the value is 1, 0. And r is equal to 0. In first case, r is equal to 29. R is equal to 29. So if we take r is equal to 29, 2 plus 29, 31, r value 29. Why? Because here x becomes 0 and remaining x coefficient is, so how to get x power 30? 29 plus 1, x power 30. So this gives x power 30 coefficient. Okay. In second case, s is equal to 1. X is equal to 1. If we take s is equal to 1, here x power becomes x square. Remaining we need to x power 28. So if we take r is equal to 27, we get x power 28. So bases are equal, we get x power 30 coefficient. So in this case, we get r is equal to 27. 7. So in second case, in second value, we get R is equal to 27. Okay. So here S is equal to 1, we get 2, 1, x square, and 29, 2 plus 7, 29, 27, x power 28. So here total coefficient x power 30. So here also, okay. So here x square and x power 28 gives the quotient for x power 20. So in third case, s is equal to 2. So 2 plus s, 3, 2, x power 2, 2 into 2, 4, x power 4. Okay. So in the remaining x power 26, we need x power 26. So for that, we have to put r is equal to 25. We have to take r value 25. So 27, 25, x power 26. So plus and so on up to s is equal to 4. We get x power 28 and r is equal to 1. So 3, 1, x square. So in total expansion, we give the values for s and r. We get the coefficient of x power 30. So the coefficient of x power 30 is 10, 1C0, 31C9 plus 2C1, 29C27 plus 3C2 into 27C25 plus 4C3 into 25C23 plus and so on plus 15C4 into 3C1. Okay. This is how we find the coefficient of number of integer solutions for given equation using given constraints. Okay. Next problem. In how many ways can 12 oranges distributed among 3 children A, B, C, so that A gets at least 4, okay? B and C gets at least 2. B and C gets at least 2. But C gets more than 5. But C gets more than 5. So we have to find how many ways can 12 oranges distributed among 3 children. So here total value is 12 and sharing for 3 children. Okay. So the given constraints are A gets at least 4. At least 4 means not less than 4. B and C gets at least 2. At least means not less than 2. Okay. But C gets more than 5. So greater than 5. These are the given constraints to share the oranges for these 3 children A, B, C. Okay. So solution, let x1 be the number of oranges which A gets. So x1 be the number of oranges which A gets, and x2 be the number of oranges which B gets, and x3 be the number of oranges which C gets. Total, how many oranges we are having? 12. So x1 plus x2 plus x3 is equal to 12. The given constraints are x1 greater than or equal to 4, x2 greater than or equal to 2. So here C gets more than 5. So x3 value is in between 2 less than or equal to x3 less than or equal to 5. So here the condition is B and C get at least 2. Here C already mentioned at least 2. And here it is given gets more than 5. This means C is in between 2 to 5. So 2 less than or equal to x3 less than or equal to 5. Okay. So we have to take x1 values from 4, 5, 6. More than, not less than 4 kabatti So x1 values 4, 5, 6 and so on. So the function for x1 is f1 of x is equal to x power 4 plus x power 5 plus x power 6 plus and so on. So totally we common x power 4. We get 1 plus x square plus and so on. So what is the expansion for 1 plus x square plus and so on? 1 minus x whole power minus 1. So f1 of x is equal to x power 4 into 1 minus x whole power minus 1. So next the condition is x2 greater than or equal to 2 means, so we have to take the integers for x2 is 2, 3, 4, 5 and so on. So the function for x2 is f2 of x is equal to x2 plus x3 plus x4 plus and so on. So we common x square, we get the function x1 plus x square plus and so on. So what is the formula for this expansion? 1 minus x whole power minus 1. Okay. So f2 of x is equal to x square into 1 minus x whole power minus 1. So next one, the condition for x3 is 2 less than or equal to x3 less than or equal to 5. So x3 value is between 2 to 5. So x3 can take the values 2, 3, 4, 5. Okay. So f3 of x is equal to 2 x square plus x cube plus x power 4 plus x power 5. So hence the generating function for these constants f of x is equal to f1 of x into f2 of x into f3 of x. So f1 of x is equal to x power 4 into 1 minus x whole power minus 1. f2 of x is equal to x square into 1 minus x whole power minus 1. f3 of x is equal to x square plus x cube plus x power 4 plus x power 5. Okay. So bases equal, powers we get x power 4 into x square x power 6 and x square remaining function x square plus x cube plus x power 4 plus x power 5 into 1 minus x whole power minus 2. So this is of the form, the closed form of expansion form of this function is 1 minus x whole power minus n form. The formula is summation r is equal to 0 to infinity. Here n value is 2. 2 plus r minus 1 r x power r. Okay. So we common here x square x power 8 into 1 plus x square plus x cube. Summation r is equal to 0 to infinity. 2 minus 1 1 plus r r x r. Using this relation, we have to find the how many ways we have to distribute these 12 oranges to the children A, B, C. Okay. So that means we have to find the coefficient of x power 12 using this relation. So here in first case x power 8 into x power r. Okay. So x power, here how many cases arise? X power 8 into x power r and x power 9 into x power r and x power 10 into x power r and x power 11 into x power r. 4 cases arise. So here x power 8 into x power r. We totally we need x power 12. So in first case we take r is equal to 4. So in first case we take r is equal to 4. 1 plus 4, 5, 4. Okay. Plus in second case means x power 8 into x power 9. So x power 9 into, in first case, x power 8 into x power 4. Total value gives x power 12. So here r is equal to 4 in first case. Okay. So that's why the value 5c4 plus in second case we are having x power 9. So we need to take r value. So x is equal to r is equal to 3. So this gives total x power 12 value. So 1 plus 3, 4, 3, 4 C3 plus in third case x power 8 into x square. So x power 10, x power 10. So we have to take r value here 2, r is equal to 2. It gives total value x power 12. So we have to take r value 2. In this case we get 1 plus 2, 3, 2, 3, 2. Okay, 3c2 plus in fourth case x power 8 into x power 3 means x power 11. Okay, x power 11 into, so we have to take r is equal to 1. This total value gives the quotient of x power 12. So x power 11 into x power 1. So r value 1. 1 plus 1, 2. 2c1. So we simplify this 5 factorial by, what is the formula for NCR? N factorial by r factorial into n minus r factorial. So 5 factorial by 4 factorial into n minus r, 5 minus 4, 1 factorial plus 4 factorial by 3 factorial into 1 factorial plus 3 factorial by 2 factorial plus 2 factorial by 1 factorial. To simplify this, we get 14. 5 plus 4 plus 3 plus 2, that is equal to 14. So totally we have 14 ways to distribute 12 oranges to 3 children with their given constraints. Okay. So how many ways are possible? 14 ways are possible to distribute 12 oranges to given children, to the children A, B, C with given conditions. Okay. This is the solution for given problem. So next one, find the number of ways of forming a committee of 9 students ran from 3 different classes so that students from the same class do not have an absolute majority in the committee. So here the given how many ways of forming a committee of 9 students. Committee of 9 students. So total committee members 9 from 3 different classes, so that students from the same class do not have an absolute majority. So here same class do not have an absolute majority in the committee. So total number of committee is 9. So we have to find the number of ways we form that committee. Okay. So under the given condition, there must be at least one student from each class, and no class can have more than 4 representatives in the committee. సో వాడు ఇచ్చిన కండిషన్ ప్రకారము మనకి పాసిబిలిటీ ఏముంటుంది, ఇక్కడ 3 డిఫరెంట్ క్లాసెస్ అన్నారు కాబట్టి మస్ట్ బి అట్లీస్ట్ 1 స్టూడెంట్ ఫ్రమ్ ఈచ్ క్లాస్. సో ఆల్రెడీ 3 ఈచ్ క్లాస్ నుండి ఒక్కొక్కరిని సెలెక్ట్ చేస్తే టోటల్ ఎంత అవుతుంది 3. సో దట్ స్టూడెంట్స్ ఫ్రమ్ ది సేమ్ క్లాస్ డు నాట్ హ్యావ్ ఎన్ అబ్సల్యూట్ మెజారిటీ. అబ్సల్యూట్ మెజారిటీ ఉండకూడదు అంటే పాసిబిలిటీ ఏముంటుంది, and no class can have more than 4 representatives. If we take more than 4 representatives in the committee, so 1 1 4, so 1 2 3, the cases 1 1 1 ante conditions 3 classes nundi at least 1 1 undali. So 1 1 1, the remaining will be based on given condition. And second one, so if we take 1 1 from 1 1 class and another class from 4, okay, so the condition is 1 less than or equal to xi less than or equal to 4. Ante xi value we have to take between 1 to 4, means 1 2 3. Okay, so here the functions are f1 of x is equal to, f2 of x is equal to, f3 of x is equal to, the possible ways here x plus x square plus x3 plus x power 4. So the generating function is f1 of x into f2 of x into f3 of x, that is x plus x square plus x cube plus x power 4 whole cube. So from this we common x term, x కామన్ వస్తుంది, పవర్ లో 3 ఉంది కాబట్టి x క్యూబ్ ఇంటూ 1 ప్లస్ x స్క్వేర్ ప్లస్ x క్యూబ్ హోల్ పవర్ 3. దిస్ ఈస్ ద ఎక్స్పాన్షన్ ఫర్ 1 minus x power 4 by 1 minus x whole cube. So 1 minus x power 4 by 1 minus x whole cube. So this can be written 1 minus x power 4 whole cube into 1 minus x whole power minus 3, because 1 by 1 minus x. So that value coming to numerator 1 minus x whole power minus 3. Okay. So x cube into 1 minus x power 4 whole cube into 1 minus x whole power minus 3. So here this is of the form 1 minus x into whole power n, positive value. So 1 minus x whole power minus n. So what is the formula for this function? So summation x cube into summation r is equal to 0 to infinity. So NCR 3CR here minus x power 4 whole power r into summation s is equal to 0 to infinity. Here power value minus. So the formula is n plus r minus 1. N means 3 plus s minus 1. So 3 minus 1 becomes 2. 2 plus s x cube. Okay, x power r. So x cube. So the required number is the coefficient of total committee. What is that? 9. So we have to find the coefficient of x power 9 in this function. So we, for given values of, so this coefficient is, in first case here it is already x cube and here x cube. So for given values of r, we get r is equal to 0. So r is equal to 0 becomes, so 3 0, which gives, so here 0 value 1. Okay. And here s value 6. So here x power 3, and here we take, in first case s is equal to 6. It gives total value x power 9. Here r is equal to 0. Okay. Here r is equal to 0, x power cube into x power 6. Here it is s, x power s. Okay. So total value gives x power 9 coefficient. So the value is 3 0, 2 plus 6, 8, 8, 6. Okay. Minus, here it is, in r is equal to, next case r is equal to 1. R is equal to 1 means 3c1 minus x power 4. So that value minus, and x cube into x power 4, x power 7, and remaining x power 5. So in this case we take the value 2. So 2 plus 2, 4, 2. So s is equal to 2 here. It gives total value x power 9. Okay. So this is the 3c0, 8c6 minus 3c1, 4c2. We simplifies these calculations. 8 factorial, 3c0 value 1. So 8 factorial, 6 factorial, 8 minus 6, 2 factorial minus 3c1, 3 into 4c2, 4 factorial, 2 factorial into 2 factorial. So we get the value 10, that is equal to 10. So we have totally how many ways? 10 ways to form a committee using given constraints. Okay. So thus under the condition specified, the committee can be formed in 10 ways. So next problem. A bag contains a large number of red, green, white and black marbles with at least 24 of each color. In how many ways can one select 24 of these marbles so that there are even number of white marbles and at least 6 black marbles? Total number of marbles are 24. So how many colors are given? Red, green, white and black. So totally we have to take 4 values x1, x2, x3, x4 respectively. Represent the number of red, green, white and black marbles that can be selected. The total equation is x1 plus x2 plus x3 plus x4 is equal to 24. The given conditions for in how many ways can one select 24 of these marbles so that there are even number of white marbles and at least 6 black marbles. These are the given constraints. Using these constraints, in how many ways we select the marble from the total marble. Okay. So x1 greater than or equal to 0 and x2 greater than or equal to 0 and x3 is equal to 0. Here x3 means white marble. A given condition for white marble. So even number of white marbles. So x3 is equal to 0, 2, 4 and so on. And condition for black marble, that is at least 6. So at least 6 means not less than 6. So x4 greater than or equal to 6. These are the given conditions for taking the marbles from the total marbles. So 4 marbles, what are that? Red, green, white and black. The given condition for white marble is x3 is equal to, we have to take even number of marbles from every pick. Okay. And 0, 2, 4 and so on. So x4 greater than or equal to 4, not at least 6 black marbles. That means not less than 6. So x4 greater than or equal to 6. So using these constraints, we define the functions. So first function f1 of x is equal to, so x power 0 plus x power 1 plus x square plus and so on, and f2 of x is equal to x power 0 plus x power 1 plus x square plus and so on, and the condition for x3 is we have to pick only even number of marbles. So x power 0 plus x square plus x power 4 plus and so on, and the condition for black marble is not less than 6. So we have to start from 6. So x power 6 plus x power 7 plus x power 8 plus and so on. So the generating function for given problem is f of x is equal to f1 of x into f2 of x into f3 of x into f4 of x. So 1 plus x square plus and so on into f2 of x means 1 plus x square plus and so on, and 1 plus x square plus x power 4 plus and so on into x power 6 plus x power 7 plus x power 8 plus and so on. So what is the expansion for these? 1 minus x whole power minus 1. 1 minus x whole power minus 1. So here the series is x square plus x power 4 plus and so on. So the function binomial expansion 1 minus x square whole power minus 1. And here it is, we common x power 6, we get 1 plus x square plus and so on. So x power 16 to 1 minus x whole power minus 1. So simplify this, we get x power 16 to 1 minus x whole power minus 3 into 1 minus x square whole power minus 1. So this is again of the form 1 minus x whole power minus n. So the expansion from summation r is equal to 0 to infinity n plus r minus 1 r x power r. Here r n value 3. So 3 minus 1 2. 2 plus r x power r. Summation r is equal to 0 to infinity, not r, s. So we denote it with another variable. S is equal to 0. In place of x, we are having x square. So x square whole power s. So now we find the coefficient of total number of marbles is x power 24. So now we find the coefficient of x power 24 in this function. Okay. So now if we give the values for r and s, we get the coefficient of x power 24. Okay. In first case, r is equal to 0. In first case, r is equal to 0. This total value becomes 0 and x power 2 into s. So here s is equal to here x square into s. Okay. The total value 18. R is equal to 18. We get 2018. And next R is equal to